This video is over how to multiply and divide while in scientific notation. So when we are multiplying and dividing, we're just going to go ahead and multiply or divide, depending on the problem. And we're only going to do that with the whole numbers or the decimals. The times 10 will always stay the same. And then going back to our exponent unit, if we're multiplying in the problem, when we're multiplying, we add the exponents. And if we're dividing, just like before, when we're dividing, we subtract the exponents. Now, in order for this to work, it's important to remember that both numbers must be in scientific notation. We're going to do 10 examples. For number 1, we have the problem 3 times 10 to the 4th times 7.2 times 10 to the 2nd. So we're going to start with our numbers. We're going to multiply 7.2 times 3. 3 times 2 gives you 6. 3 times 7 gives you 21. And we put our decimal point back in our answer. When we're multiplying, we would add the exponents. So 10 to the 4th and 10 to the 2nd, we would add together to get 10 to the 6th. Now, when we have this answer, 21.6 times 10 to the 6th power is not in scientific notation. Remember, we always want that decimal to go behind the first number, so we need to move it up one place. 2.16 times 10 to the 7th power is our final answer. Notice that exponent changed when we moved the decimal point up another place value. 2.16 times 10 to the 7th is our final answer. For number 2, we're going to have the number 1.5 times 10 to the 5th, and we're going to multiply it by 5 times 10 to the 3rd. So we start with our numbers, 1.5 times 5. 5 times 5 is 25. Put down the 5, carry the 2. 5 times 1 is 5, plus 2 is 7, and put in your decimal point for an answer of 7.5. When we're multiplying, we would add the exponents. So 10 to the 5th and 10 to the 3rd would add together to give us 10 to the 8th. And our answer is 7.5 times 10 to the 8th power. We don't have to move the decimal point in this answer because the decimal point is already behind the first number, 7. So our answer stays 7.5 times 10 to the 8th. For number 3, we have the problem 9 times 10 to the 9th, and we're going to divide it by 3 times 10 to the 7th. So starting out, if we do 9 divided by 3, we end up with 3. And if we're dividing, we would subtract our exponents, 10 to the 9th and 10 to the 7th. If we subtract those, we would get 10 to the 2nd power. 9 minus 7 would give us 2. And so our answer would be 3 times 10 to the 2nd power. We do not have to move a decimal point because in a whole number, the decimal is already behind the first number, 3. And so our answer would stay 3 times 10 to the 2nd power. For number 4, we're going to have the number 9.45 times 10 to the 7th divided by 2.1 times 10 to the 2nd power. We're going to start by dividing our numbers, 2.1 into 9.45. When we're dividing decimals, it's been a while since we've done this, you move the decimal point so it's at the back. And what you do to one side, so we moved that one time to make it 21, so we moved that decimal point one time to make it 94.5. And then we move the decimal point straight up in our answer. Now, 21 cannot fit inside of 9, but 21 can go into 94. 21 can go into 94 4 times. 21 times 4 is 84. Subtract, and we would get 10. Bring down the 5. 21 can go into 105 5 times. 5 times 21 is 105. Subtract, and we get 0. Now, when it comes to our exponents, if we're dividing, we're going to subtract our exponents. 10 to the 7th minus 10 to the 2nd. 7 minus 2 would give us 5. So our answer would be 4.5 times 10 to the 7th power. We don't have to move any decimal points in our answer because the decimal point is already behind the first number, 4. The answer stays 4.5 times 10 to the 7th power. For number 5, we're going to multiply the number 0.000012 by the number 6 times 10 to the negative 2nd. Now remember, I told you earlier that in order to use this method of solving our multiplying and dividing problems, we need both numbers to be in scientific notation, meaning we need to move the decimal 1, 2, 3, 4, 5 times for that first number. My answer becomes 1.2 times 10, and it would be to the negative 5th power because all the zeros in the front are representative of a negative exponent. And then we can multiply it by 6 times 10 to the negative 2nd. So 1.2 times 6. 6 times 2 is 12. Put down the 2, carry the 1. 6 times 1 is 6, plus 1 is 7. Put your decimal point back in your answer. With our exponents, when we're multiplying, we would add our exponents together. Negative 5 plus negative 2 would get us negative 7. And so when we write our final answer, it would be 7.2, always times 10 to the negative 7th power. We don't have to move any decimal points in our answer because the decimal point is already behind the first number, 7. The answer stays 7.2 times 10 to the negative 7th. For problem number 6, we're going to take the number 7.3 times 10 to the negative 1st, and we're going to multiply it by 0.004. Again, I mentioned in the beginning, we need to have both numbers be in scientific notation in order to multiply or divide them. So for the second number, we're going to move the decimal point 3 times so that it ends up at the back. The 7.3 times 10 to the negative 1st is already in scientific notation, so it's good to stay the same. The second number changes to 4 times 10, and it would be to the negative 3rd power. 3 because we move the decimal 3 times, and negative 3 because there's zeros in the front. Now, we can actually go ahead and multiply our numbers. 7.3 times 4. 3 times 4 is 12. Put down the 1, carry the 2. 7 times 4 is 28, plus 1 is 29, and add your decimal point back in. When it comes to your exponents, 10 to the negative 1st and 10 to the negative 3rd, when we're multiplying, we add the exponents. Negative 1 and negative 3 would give us a negative 4. Our answer would be 29.2 times 10 to the negative 4th power, but that answer is not in scientific notation. The decimal point needs to go behind the first number. The first number is a 2, so we need to move it up 1 place. That changes our answer to 2.92. It also changes our exponent from a negative 4. We go up to a negative 3. 2.92 times 10 to the negative 3rd is our final answer. For number 7, we're going to have the number 6 times 10 to the negative 3rd, and we're going to divide it by 0.00003. Again, as mentioned earlier, we need both numbers to be in scientific notation. The top number, 6 times 10 to the negative 3rd, is good to go ahead and solve, but the bottom number needs to be rewritten. We move the decimal 1, 2, 3, 4, 5 times, so it's behind the first number. And so we can rewrite our problem as 6 times 10 to the negative third, and then 3 times 10 to the negative fifth. Now, when we divide, 6 divided by 3 is just going to give us 2. And when we're dividing, we would subtract our exponents. Now, negative 3 minus 5 is actually a tricky problem. You need to write it out. Negative 3 minus negative 5. We cannot solve problems where you have a minus and a negative together. We have to keep change, and we change those to addition because you can't have a negative and a minus sign side by side. It does not work in math. Negative 3 plus 5 would give you a positive 2. Our answer would be 2 times 10 to the second power. For number 8, we're going to have the number 0.00096 divided by 1.2 times 10 to the negative 8th. The bottom number is already written in scientific notation, so it's good to stay the same. But the top number, 0.00096, needs to be rewritten. So we're going to move the decimal behind the first number 9, and we move it 1, 2, 3, 4 times. We can write that as 9.6, always times 10, and it would be to the negative 4th power. 4, because that's how many times we move the decimal point, and it's negative because the zeros in the front mean it's a negative exponent. Now we can go ahead and set up our division problem. When you're dividing decimals, you cannot have a decimal in the divisor, so we can go ahead and move that over one place to make that 12, and we move it over the same amount of time to make that 96. 12 can go into 96 8 times. 8 times 12 is 96. Subtract and we get 0. When it comes to our exponents, if we're dividing, we would subtract our exponents. Now this is a trickier problem. Negative 4 minus negative 8 cannot be solved in math because you cannot have a minus and a negative side by side. When that happens, we change them to addition signs. Negative 4 plus 8 is going to give us a positive 4 for our exponent. 8 times 10 to the 4th power is our final answer. For number 9, we're going to take the number 2.5 times 10 to the 7th. We're going to divide it by 4 times 10 to the 4th. So we're going to start with our 2.5 and we're going to divide it by 4. 4 cannot fit inside of 2, so we go straight into 25. 4 can go into 25 6 times because 4 times 6 is going to give us 24. And 24 is close to 25. Now, 25 minus 24 is going to give us a remainder of 1. We don't want a remainder, so we add a 0, bring it down. 4 can go into 10 2 times because 4 times 2 is 8, and that's close to 10. Again, when we subtract, 10 minus 8 is 2. We don't want a remainder, so we're going to add a 0 and bring it down. 4 can go into 20 5 times because 4 times 5 is 20. So that is our decimal point, 0.625. Now, when we're dividing, we would subtract our exponents, 10 to the 7th minus 10 to the 4th. 7 minus 4 would give us 3. And so our answer would be 0.625 times 10 to the 3rd power. However, this answer is not in scientific notation. The decimal point needs to go behind the first number, 6. So we move the decimal point back one place to make it 6.25. When we move the decimal back one place, that 3 goes back to a 2. 6.25 times 10 to the 2nd is our final answer. For our last problem, we have 1 times 10 to the 2nd, and we're going to multiply it by 5.2256 times 10 to the 5th. So we're going to start by multiplying our numbers. 6 times 1 is 6, 5 times 1 is 5, 2 times 1 is 2, Keep that decimal point. 5 times 1 is 5. When it comes to our exponents, if we are multiplying, we would add the exponents together. 10 to the 2nd and 10 to the 5th add together to give us 10 to the 7th. And so our answer, 5.256 times 10 to the 7th power, is our final answer. Because the decimal point is behind the first number, we do not have to move it to find our final answer. It stays 5.256 times 10 to the 7th.